and Professor Amit Sheth from South Carolina University is going to give the talk. Thank you.
Exciting sessions, demonstration and all. Now we have our keynote topic. So this is my absolute honor and privilege to introduce our distinguished speaker today, a pioneer and visionary, Professor Amit Sheth. Professor Sheth is an educator, researcher, and entrepreneur of global repute. He currently serves as the NCR Chair and Professor of Computer Science and Engineering at the University of South Carolina, where he also founded and led the university-wide AI Institute. His works bridges academia and real-world innovation, and his career reflects a rare blend of scholarly excellence and success. He is also a fellow of 5 leading professional organizations like IEEE, IIIA, AAAS, and ASM. Among his many accolades are the prestigious IEEE Computer Society WLS McDowell Award, the IEEE Technical Services Research Innovation Award, BITS Pilani Distinguished Alumni Award, and the Ohio State University Alumni Academic Excellence Award. Professor Sheth has co-founded 4 companies, including a first semantic search company as early as 1999, 9 years ahead of its time, laying the foundation for what we now recognize in technologies like Google's semantic search and knowledge graph. His ventures like EasyDI and Cognovi Labs continue to push the frontiers of AI in healthcare and emotional intelligence, respectively. And perhaps what he's most proud of, and rightly so, is his mentorship with over 45 PhD graduates and postdocs who have gone on to excel in academia, industry research, and entrepreneurship. Professor Seth's legacy is as much about empowering future leaders as it is about advancing the technology. Please join me warmly welcoming Professor Amit Sheth. Sir, we all welcome you and thank you for your time. It's early morning for you, but still you have joined us. So thank you and over to you.
Thank you very much, Smriti-ji. Sorry, I have to join you at the end of your day because of our time difference. I hope you'll find this presentation useful. My general theme of presentation today is what are the significant important things to come in AI that are of practical importance. There is amazing progress in AI, and every day brings new capabilities, new innovations. And a lot of them is in what is called as large language models recently, and that is a part of GenAI. And this whole workshop, that a whole seminar, conference that you have is on GenAI. So I wanted to talk about some important changes that I think will come that will be of very important practical importance, especially from the viewpoint of India. For example, it may be that development of very large-scale, large language model with trillion parameters may not be something that India may want to develop. It costs massive resources and big expenses. and 5-7 companies in the world are building those kind of models. But there is so much more to do, where there is a business and otherwise other human needs. And I think the kind of things that I'm going to talk about are the ones that hopefully will be important in intellectual property development, IP development, that can drive AI-driven products and help India move towards product nation. So LLMs, let's start with LLMs. They shine in number of things. Anything about genetic content, they consume a vast amount of practically everything that is out online. They have something called common crawl or fine web, massive collections of everything that is online. And then they have this ability to, meaningfully connect the things in response to your prompt and give you a very cogent answer. Textual coherence, it is very hard to distinguish. It is in fact impossible to distinguish between human-generated text, at least in English, and computer LLM-generated text. And so they are excellent for language-based tasks like writing, summarizing, and translating. Natural language interactions, including conversations, chatbots, increasingly applied to also voice, a virtual assistant, interactive systems, they are great help. Entity extraction, information retrieval, getting some specific information, as well as productivity and assistive tools. These things they do very well. And there are some risks that can be mitigated. It is well known that the LLMs or these generative AI technologies have these hallucinations. They make up the facts. And in fact, it is currently it is not known how you can control them to not make up the facts. What I mean is that they make up untruth or false information. So these kind of errors, for example, one of the best models, latest models, is known to have, the one from OpenAI is known to have over 30% hallucination rate, meaning almost 3 in 10 of all the results have something that actually is not based on any facts or data. It is made up in a way by synthesis. Now they do creative enhancement, and that may be okay because it's creative work, so that's fine. To mitigate risk, you can also have impose some sort of structure and create a workflow. There are concerns on de-skilling, meaning the increasing number of papers that show that those who are using, let's say, ChatGPT may not develop creative thinking skills as much as others would have to when they have to work hard. Sometimes it is not clear whether humans need that or not, because we were worried that when we had calculators, we'll forget how to do multiplications. But that did not end up being very bad. It's okay for computers or technology to do that. Skill atrophy across career stages. So yeah, if you de-skill, meaning you lose certain approach capabilities, then you might become more outdated over time, and things of that nature. So there are various limitations of LLM. Primarily, they were designed for words. Although I must say that now they are being designed very well for images and video. Still, numbers, there is some progress, and symbols, there is some progress, but there is more to go. They're very data hungry, they're very energy hungry, they're black box, so we don't know, they lack interpretability. Also, they may be misaligned with human values. We have societal values, we have rules, regulations, policies, ethical standards that they may not be able to follow. and then adapting them for, because they are made for, dealing with everything in the world. Very specific requirement of particular domain or application may not be supported that well. So in that context, generally I would like to distinguish between use of generative AI for information assistance, and there they are doing very well. The generative AI is exceptionally well in such things, with the caveats like ones I mentioned, such as hallucination and but on the decision making assistance and on things that are mission critical, where you can't have any errors, where accuracy has to be 100%, where it should be based on existing data or science, or should be grounded in the facts, there they are not quite ready. So when you to do planning, reasoning, and many other applications I've shown here under B2B, they are they can be weak. But what is very important is that in general, for consumer use, technologies like ChatGPT has done wonders. However, when you look at enterprise use, there is a challenge. So there are different estimate, but AI can do only 5 to 10% of all the human jobs, is what you hear all the time through variety of sources. And recently Gartner came out with a very interesting observation, something that I have been making for some time, saying more than 50% of applications will be for enterprise use. And currently there is not as much enterprise use as there is use on consumer. So use of ChatGPT by everybody in the world, far outpaces the use in a very specific industrial uses, or and for that the current models, as the ones like that go into developing large language models, may not be the most appropriate thing to do, and that is what I'm going to talk to you about. So hallucination is something I talked to about, and look at the quote at the top. In enterprises, if you are brilliant 95% of the time and ridiculous 5% of the time, you are dead in the water. What it means is that if you have 1, 2, 3, 4, 5% errors, those errors could be very expensive, and you cannot, so you should not rely on the technology like that. If the error leads to, railway going off the track, or error leads to, reaching some wrong destination, or error leads to, machinery stopping on the shop floor, manufacturing, that would not be acceptable. So when you have to develop very high fidelity, reliable model, what we have today in GenAI is not ready. Another interesting thing is, you need an army for building these large language models or robust model. There is a set of models called GenAI models from IBM, and here is a paper from them, and it is, and there is Gemini. You'll find that you have 50 to 250 researchers and engineers working on developing them, and this is a very, very big effort, and it requires at least a few people with extremely high experience, not just in the algorithms but also in the systems, how efficiently are GPU used, and how efficiently and how appropriately the memories are used. All those work have to be done. Now, at least as I observed, currently in India, there isn't one place that has all that skill, with the possible exceptions where companies like Sarvam have brought together 100, 200 people, but I wouldn't know whether they have all the same skills that some of these top line models have. We are making progress in India, but all I want to say is that it is a massive undertaking, very expensive undertaking, and that there are other alternatives where AI can, where you don't have to invest so much in AI and you can get a lot of value. So um, LLMs are likely not the solution for a significant subset of real world problems which require intelligent, robust, and trustworthy AI. So I put in a few points here. These are repeats, so I won't go through all of them. They're unreliable and inaccurate. They may not work that well in complex enterprise applications. They may work very well. For example, you may have some part in the middle of a decision-making process that is conditioned on what is there in the ground today, right now. Let's say some sensor reading. You have to make sure that some sensor is within limit before you start processing. These kind of things, which is also called embodied AI, is an emerging discipline, but not quite developed yet. Privacy and security issues are there, although you can generate many of these models locally to to take care of this problem. They are overpromised, especially in the area of reasoning, analogy, and such. So they do simpler job very well, but complex job they don't do well, and you don't know whether they're doing it well or not. That's the bigger problem. And then you end up a lot of effort after you get something from a large language model in the form of such a RAG, or in form of very extensive prompt engineering and integration with knowledge graph and so on and so forth. Okay, so there is a very rapidly growing area called agentic AI, and if you can combine these language models with tools of various kinds, you can make progress. However, there are still a lot of there's still a lot of way to go. It is an interesting dimension where you can break down the problem in multiple steps and have more control over what happens as a part of the process with multiple agents participating. However, they have shown to be there's a lot more work to be done. They are certainly one place where you would make progress. So, broad observation I have is that AI typically in most cases doesn't solve the problem, but humans can use the AI to solve the problem well. And so AI can help improve productivity and efficiency. GenAI, when it can be used correctly, is the kind of thing that you want to do. The large language models that are out there are getting quickly commoditized. So recent observation is that you won't see much improvement by increasing the scale. So just adding more data doesn't help, because there is just not much more data available, and either they are using synthetic data, or a lot of data is created by other AI systems and is available online, and so that is called contamination. So that's a big problem. There's a copyright issue, but it is very there's some recent court rulings about that. I won't go into detail on that because we don't have time. Frontier models is where there is more action, meaning against foundation model. So what we have currently, GPT 4 or all these are foundation models, and frontier models are more specialized. That is, for example, you develop a model for synthesized biological or chemical weapons, or spread of disinformation, or Kisan AI in India, which is for agriculture. Those are very, very valuable. And then you want to, you will need to develop composite AI systems, where model is just one component, but there are many other, but there are different components that may use different models to perform complex tasks. So there will be hybrid system. Okay. So with that in mind, we have proposed next generation of AI architecture. We call it custom, compact, and composite using neurosymbolic AI. So I put down on the right hand side and in the figure evaluation of AI, monolithic, multi-tool, multi-agent AI, co-pilots, which is happening now, co-pilots and agents. And then we are working on the C3N, a fourth generation that integrates neurosymbolic, reasoning, human feedback, and enterprise workflows. So there is a paper available, and you can find a lot more details on that also if you want to study it after my talk. So let us look at the component of what we are proposing. Compact, in that there is a growing work and growing success in building what is called as small language models, right? So I think that this is a great direction, and with the small language models that can do as good as, in some cases better than large language model for a specific task. So small language models may not be, may not compete with large language models for broad-based tasks, but may be better than a large language model for a very well-defined task. The next thing is, and because they are small, they can be deployed in variety of constrained environments. The next is custom. So you are developing model that is solving very specific issues or problems. So they involve a domain-specific knowledge and workflow. So if I am doing it for health, I will only have health-related data for its training and for its fine-tuning. If I am using doing it for manufacturing, I will only have manufacturing data and fine-tune. I may complement the language model and use API in some complementary way, but basically the idea here is to focus and do solve the problem that you want to solve better. And that is a very interesting opportunity for us. That way you are solving a problem that large language models cannot solve well, and your products and services could stand out. To me, this is an approach that could help India become a product nation driven by AI. Composite, that is integrates multiple AI modules, neural networks, knowledge graph, symbolic models. They support complex tasks by orchestrating various specialized components, and in a way, these multi-agent systems are a framework for doing this. Enhance decision making by combining diverse data sources and reasoning method. The last and very important thing is neurosymbolic. This is something that my team has worked on for a very long time and are one of the pioneers. So this involves combining not just data but knowledge and human expertise. Traditional generative AI systems is largely, when you look at large language model, it is largely the product of training on vast amount of data. Although something like RLHF or human involvement does improve it, and it's a very important component. But we have been thinking about much more broad-based use of data, knowledge, and human expertise in developing this next generation of model. And so there are approaches called knowledge infusion, where we take the knowledge and infuse it or integrate it with the neural networks, and knowledge elicitation, where we extract knowledge from language models and combine with external knowledge. So this is a new class of models, or technology that is coming out, and we very much advocate their use. So use of these neurosymbolic techniques have shown improvement in medical diagnosis, in enterprise question answering, like in insurance database, in anomaly detection, in autonomous agent, for example, one that is used in driving. So I have put together here some very specific examples of cases where, compared to primarily neural network based generative AI, use of neurosymbolic AI has resulted in better results, primarily because extensive use of human knowledge about that particular domain. So particularly captured in knowledge graph, or in some cases as logic or rules. So the general idea for neurosymbolic AI is the following: that there's a Nobel economic prize winning work called Thinking Fast and Thinking Slow by Daniel Kahneman. So he has talked about this theory, behavioral economic theory, and he talks about certain tasks where human makes immediate decisions or fast decisions, and certain tasks where human cognition is involved and takes slower decisions, but more deliberate decisions. And we do both. So, for example, we have what we call as perception. Perception is like you're driving and you are seeing from the corner of your eye a ball comes in on the road. You're human. You notice that is a danger. Maybe because of the ball, there may be a child playing cricket or football, and that could be a you have to be very careful about it. And that happens on a extremely fast basis, and this is part of human perception. And there is cognition, where we think for a while, and we plan. Say, I want to get this kind of job. So to get that kind of job, what are the things I need to do? I need to do this course. I need to do this internship. I need to all these things that you're planning out and executing over the period of time. That is what is called as system 2. Even independently of the Daniel Kahneman's work, very, very highly, I guess, influential work, I had written a piece which is called Semantic, Cognitive and Perceptual Computing, Paradigms that Shape Human Experience, which also talked about some similar thing, as the perceptual and cognitive and use of semantics to combine them. Now, think about what is happening in your brain as you are listening to me. You have knowledge of English, structure, grammar, language grammar, and structure, right? And so, like parsing, or like where my comma, where I'm stopping. That is one type of knowledge you have. Second is linguistic knowledge, like the kind of things that will be in a word net, the words that have synonyms, and this word is related to this word. Then there is a common sense knowledge. A lot of things you know for sure, and you observe that over a period of time, and that can be you are applying that also when you are listening to me. Then there is some very specific factual knowledge, general purpose factual knowledge. Bhubaneswar is the capital of Orissa. That is a knowledge that you have. That is general purpose. And then there is domain specific knowledge. All of you have some knowledge about generative AI. So your domain is AI, and you have some knowledge of AI, and you're using that knowledge to also further understand what I'm saying right now, what I'm showing you right now, right? So this is a multi-tier processing that is going on in your brain. All this knowledge that I'm showing provides semantics to connect the perceptual and cognitive components. Okay, so the now this leads to a framework. A framework consists of 3 pillars: intelligence, robustness, and trustworthiness. Right? So these are important aspects of what enterprise applications need. And then we identify 14 elements that are important for all these 3 pillars, supporting these 3 pillars, and making AI worthy for demanding enterprise applications. Right? So then let us see various components of that. What are the elements, or foundational elements that support intelligence behavior by an AI system? So it's planning, reasoning, instructability, causality, abstraction, and analogy. Then what makes things robust? And that they are alignment, consistency, reliability, and safety, and trustworthy. They are interpretability, attribution, explainability, and grounding. So these are all the subjects that are now increasingly being defined, and say that we need our AI system to support all of these, or at least a subset of these. When you look at GenAI, current GenAI, you find that these things are not supported. They are, one of the main reasons is because all of these neural network based systems are black boxes, right? We have a paper called Semantics in a Black Box. You can look it up and get a lot more about this. So the idea here is that we need to further improve our AI technology, GenAI technology, such that they support all of this. And we argue that neurosymbolic approach is a way to make significant progress along this line. Having done this, then we have developed a variety of very demanding and complex enterprise application, and I'm going to show you a couple of them today. One of the very exciting things we are doing here is to create a platform so that we can create this next generation of C3 AI models much more efficiently. And with that, if we provide this model, let's say to startups in India, what you can do is to develop, the Indian company startup would be able to develop their AI model on which they hold complete intellectual property right at a fraction of the cost. Of course, these things use GPUs, and India AI Pro has now 35,000 GPUs that you can access at a subsidized cost. There are a variety of other facilities available for support and funding from the government. And then what we want to do is to make it far more effective and easy for people to, for companies to develop their models and own their models, their unique models, because the models that we are talking about here are highly customized. Remember, we are doing custom, compact, neurosymbolic, and composite, right? So this requires a lot of different capabilities. Some of you may have heard of machine learning pipeline system. So you have a variety of components involved in creating a machine learning model system. Well, similarly, there's a lot more involved here now to create this next generation of models, and we want to provide a platform such that these models can be developed at scale with efficiency, and then Indian companies can build enterprise products in a particular market and have penetration. Okay, so let me show you now some example applications.
In today's diverse...
Are you able to hear? I just want to make sure you are able to hear.
Yes, sir.
Okay.
Educational landscape, supporting every student's unique needs is more critical than ever. Educators need a comprehensive framework that allows them to address academic and behavioral challenges effectively and inclusively. Enter MTSS, the multi-tiered system of supports. MTSS is a 3-tiered proactive intervention system designed to help schools support students through key components like universal screening at the start of the school year to identify student needs early, tiered interventions that adapt in intensity based on student progress, continuous data collection for ongoing assessment and improvement, a school-wide approach to consistent expectations and supports, active parent involvement to ensure holistic student growth. The MTSS team is a collective effort involving teachers, counselors, mental health support staff, administrators, and more, all working together to create a supportive learning environment. But what if an AI system could enhance this teamwork? That's where the MTSS AI system comes into play. To meet the specific needs of the AI system, we have 3 unique features: custom, compact, and neurosymbolic. Let's break down how these elements work together. The system is custom built, trained on domain-specific data to act as a specialized concierge. It's compact, made up of small modular components like user-specific copilots tailored to each MTSS team member's role, reasoning, planning, and search systems that incorporate both neural networks and symbolic AI to facilitate alignment and instructability through human expertise. Feedback mechanisms and dynamic knowledge update to keep the system at par with the ongoing interventions. This hybrid AI approach, blending neural networks with symbolic systems, is not just innovative, it's built with safety in mind. Grounding the system in human expertise ensures that recommendations are reliable, consistent, explainable, and significantly less prone to errors or hallucinations. Designed for schools, this system is aligned with AI safety principles. By tailoring its copilots to the needs of educators, counselors, and administrators, it ensures that responses are both context-specific and role-appropriate. In South Carolina, where state law mandates MTSS in every school district, the shortage of counselors is a critical issue. With an average of one counselor for every 1,300 students, this system offers a much-needed solution. The MTSS AI Concierge is poised to bridge this gap, making support more accessible for educators, counselors, and, most importantly, students.
Okay, let us look at another one. I'll do a short poem here.
Every meal impacts your health, so why not make every choice count? Introducing Nourish, your personalized AI co-pilot for smarter eating, powered by a custom, compact, and neurosymbolic model. It offers real-time personalized dietary analysis. Nourish is a specialized AI model for food and nutrition. With access to millions of recipes and semantically grounded knowledge from diverse sources, including disease-specific insights and personalized health information, it offers tailored meal recommendations and recipe modifications designed to meet your unique needs. With the power of the Common Metadata Framework, in collaboration with HP Enterprise, we ensure traceability and AI governance, so you know every decision is safe, transparent, and trustworthy. Nourish is more than just a recommendation tool. It's your trusted co-pilot for healthier living. Together, we're shaping a future where personalized nutrition is available to everyone. Every meal impacts you.
Okay, let's look at this. I may come up with the third application shortly. Okay, the thing to notice here is that these applications are far more complicated than in general, when you have used generative AI. In this, we have a whole system for supporting school behavioral mental health, and you have educators, you have administrators, you have counselors, and physicians, and your family. And there is a different level of support, meaning medical or other supervision that has to be provided depending upon the problem or challenge that the student is facing in classroom. General care instruction is tier 1, targeted interaction and group therapy is tier 2, and intensive one-on-one intervention is tier 3. So you have to figure out what kind of resources each of these cost more. Going from tier 1 to 2 to 3 costs more money. So you have to figure out what is the appropriate care and support that the student has to be provided so the students can have good education. And as you saw in the video, there are these issues of alignment. This is very important because what we are doing here is to build co-pilots. Co-pilots are sort of agents that can work with the AI model and the human. And there are humans that are doing different functions. You have nurse, you have counselor, there's a school level counselor and district level counselor. Each of them have different jobs in supporting this particular MTSS. Your agents or co-pilots must understand their needs and the constraints. They can only do certain job, but not some other things. They can make certain decisions, but not other decisions, and they need to collaborate with each other. And so alignment is to align the use of AI system to the different human roles. There are different kinds of reasoning involved, objective and deductive reasoning. And grounding that you need to ground into certain facts and data in this context. One of the 14 elements is that of knowledge. So let me give you just one slide, brief introduction of knowledge. You can see the text really struggling with my bisexuality, which is causing chaos in my relationship with a girl. Now, when you suppose you want to say use an AI system to say, is this OCD or not? The typical thing that you get is now things are improving, by the way, but typical things that you would get is classification, but exact explanation as to why it is OCD or why it is not typically is very hard to get. Today's ChatGPT kind of system will give you that, saying why. But when you look at detail, there will be a lot of errors there. Here what is happening is that we do mapping of concepts from the unstructured text onto knowledge, that is a part of knowledge graph. There is this, on the left hand side in the gray you see medical knowledge. And then use that to see how well the medical definition of obsessive compulsive disorder is supported or not supported, and then we are able to explain this is the reason why this is OCD or not. Okay, and when we look at this MTSS AI Concierge, which is our name of the application that we are developing, you see how each of the 14 elements are supported. Right? So, for example, alignment is adhering to students' behavioral objectives, referencing district framework and teacher council. Interpretability is to provide transparency into how student performance and past intervention influence recommended strategies. Right? So you can see, safety prohibits psychological harmful interventions by combining domain rules and counselor approvals. So doing all these things is what this AI system is supposed to do, and it takes a lot more machinery compared to what your current existing AI system can do. There is this here. There is a system, a very well-known system from Microsoft called a framework for building AI agents and application. And on the left-hand side, we show how you can try to implement, the decision-making reasoning in here with AutoGen. However, there are problems, number of problems, including, ones that are mentioned here is issued here, right? So on the right-hand side shows our strategy where we use process knowledge, the guidelines that are there in a multi-agent planning setup, and deal with those, and hence we don't have those issues. And then we have done some evaluation diagnosis assistance exam where by incorporating so you can see that we start with AutoGen and the results are not good. Then we added a chain of thought kind of stuff and or graph of thought. And results improved. Then we added process knowledge schema. Result further improved, and then we added process knowledge schema with few short examples. Improvement, and then we are currently working on C3AN, and we expect it will still be better. Now let me take you through the one more application here.
In today's rapidly evolving manufacturing environment, efficiency, precision, and adaptability are crucial. Introducing Smart Pilot, the agent-based co-pilot for intelligent manufacturing. Our co-pilot consists of 3 customized agents, each designed to tackle critical aspects of manufacturing. These agents are connected to a robust architecture. This framework includes the inputs for each agent, the main components of each agent, and their interactions. The Predict Acts agent identifies and predicts anomalies before they occur. alerting in real time to prevent disruptions. Next, the foresight agent analyzes product data to anticipate product fluctuations, providing insights and alerts on unexpected events to ensure smooth operations. And finally, the info guide agent acts as a Q&A chatbot, ready to assist with domain-specific queries and generate responses tailored to user needs. We utilize Future Factory's multimodal dataset that includes time series data and images. We also utilize manufacturing-specific manuals that are based on the machinery, robots, and sensors available in the Future Factory setup. Beyond data, the Copilot integrates knowledge sources, process ontology developed for this dataset. Smart Pilot is currently deployed in a rocket manufacturing assembly pipeline. Upon accessing Smart Pilot, the main UI includes 3 buttons to connect with the 3 agents. PredictX connects with the deployment server by an OPC UI server, retrieving real-time sensor data and capturing images from the cameras. It integrates with the manufacturing-based process ontology on a local Neo4j server by a Docker. PredictX model is developed upon 3 primary novel approaches in multimodal learning: time series and image-based decision-level fusion, transfer learning for fusion and knowledge-infused learning that utilizes the process ontology that we design and develop. PredictX interface includes 2 windows. The first allows users to access with the prediction dashboard. Once the assembly process begins, the system will display the current cycle state along with the real-time sensor data. Based on this information, the sensor values for the next time step, along with any predicted anomaly related to missing body parts of the rocket, will also be predicted. Once anomalies are predicted, the second window provides user-level explanations. These includes details on which variables are responsible for the anomalies, the functions performed by the robots at each state, and the expected values of those variables. Foresight interface also connects with the deployment server by an OPC UI server to retrieve real-time sensor data. It also retrieves external knowledge from several structured data sources to get information on raw materials that produce products. The Foresight agent employs an LSTM-based model for production forecasting using 30 time-step historical data from target variables as inputs. This architecture includes 2 LSTM layers to capture temporal dependencies, with additional features infused at the final dense layer. Once the production process begins, the Foresight interface displays real-time product details of rockets and forecasts the forecasted number of rockets for the next hour. The InfoGuide agent functions as an intelligent question and answer chatbot. Upon accessing InfoGuide, the user interface allows the effortless integration with the manufacturing facility as a plug-and-play device. Once the user asks a question, it first retrieves the initial context through keyword matching. If the initial context is related to anomalies, InfoGuide invokes the PredictX agent. And if the context is related to production, it invokes Foresight agent respectively. If in other contexts, it uses meaningful text derived from manufacturing manuals to provide answers to contextually rich manufacturing-specific questions. In that case, the system uses retrieval-augmented generation to find the top K-relevant contexts based on 2 similarity measures, which are neural context retrieval, using cosine similarity with BERT embeddings, and in symbolic context retrieval, using Jacquard similarity with tokenized keywords. If the similarity score exceeds the set threshold, the user query, agent-specific template, and retrieved context from agents are sent to the mixtural language model to generate a coherent response. If the score falls below the threshold, the system refrains from providing an answer, effectively mitigating the risk of generating hallucinated responses. For safety and ethical compliance, InfoGuide is programmed to avoid responses to unsafe, unethical, and unrelated queries, ensuring that all responses are aligned with ethical standards. With Smart Pilot, you are not just improving your manufacturing process, you are future-proofing it. Experience the next level of manufacturing intelligence.
Okay, so you got a sense into the Smart Pilot already, I think, and then again, here are some of the, how details on the 14 elements. What I want you to understand here is that the systems that we develop and they are really valuable are very relatively a lot more complicated, and that there is a world way beyond the traditional use of generative AI to create content and create a report and do a knowledge management task. And that the future of the AI is more along this line than the traditional generative AI line. The last of the application, Nourish, which gives disease-specific application. I just want to give you a couple of points about it. This is a very complex application because food and eating is and cooking and eating is very challenging, topic. You need to understand ingredients, which ingredients are good for what medical condition or diet condition, what kind of cooking methods you use. For example, deep fry may generate certain, components that may not be good for that particular condition. And then interactions between cooking method and ingredients. You need to know recipe. You need to understand, and explain. For example, for a diabetic patient, potato is a healthy carbohydrate, but canola oil is unrefined good fat. Deep frying is trans fat, which is not good. Potato plus frying is a loss of vitamin A, C. Whether there is allergen, whether there is calorie, and all that. So you have to do what is called as compositional reasoning, involving all these different elements to come to an answer. And then there is a corresponding, this architecture of the image. There is this also is a multimodal, application, multimodal process knowledge graph. So this has various, food and their and recipe and their images and understanding some of these images and then reasoning about them. Rules like grilling meat creates traces of carcinogens. Temperature greater than smoking point creates trans fat. Deep frying means trans fat. Right. So these are the things that you need to understand, apply. And then to come up with the recommendation, again, you have to use, so as you can see, image to text conversion is there, ingredient extraction, cooking action extraction, relationship extraction, and then reasoning. All these come into create a this complex application. Here I'm showing you that symbolic component, which is not something that generative, neural networks too much care about. Is very critical here for knowledge graph based Bayesian inferencing necessary for supporting compositional reasoning for such application. And then you have this 14 foundational element that it involves multiple types of reasoning: path based reasoning, causal relationship reasoning, counterfactual reasoning, analogical reasoning, multi-contextual reasoning, hierarchical reasoning, virtual reasoning. So, okay, so that is basically what I wanted to share with you. Very briefly, AI Institute that I founded in 2019 does both foundational AI research, which is in the inner ellipse, and translational and applied AI research with all the different areas which is on the outside. And you saw some of the applications. These applications are not just done by AI researchers or computer scientists. They all involve people who are actually working on those applications in other disciplines. So we work with epidemiologists, and we work with psychologists that work on school behavioral health. We work with manufacturing people and for smart pilot. We work with nutritionists for the Nourish. And this is the kind of work that we typically do, which is why the work we do is fairly influential. Our students are exceptionally successful. One of the reasons is because they have lots of hands-on knowledge, lots of knowledge and ability to work on real-world problems and latest research. All these are combined along with teamwork, along with mentoring skills, along with communication skills, along with presentation skills, empathy. social skills, all of these are necessary for our students to be very successful. So these are, my immediate team as well as the, the institute itself. Okay, with that, let me open up for any questions or comment that you guys may have.
Hello, sir. Can you hear me?
Yeah.
Yeah. So I have a question regarding the first part of your presentation where you said that B2B is a space where LLMs are not going to take over a lot, if I'm correct, right?
They are not adequate. So they are not adequate for B2B applications. It requires, see, the 14 elements that I argued for.
Yeah.
For B2B and enterprise application, basically, let me put it this way, you need more support for these 14 elements, and the LLMs by themselves are not good at supporting many of these elements.
Yeah, but are we like underestimating LLM's impact on B2B jobs basically by considering the current capability of the LLMs?
No, I mean, we should not underestimate the impact. There is a substantial impact on business jobs, that is for sure. So I'm not implying that LLMs don't have substantial impact on jobs. That is, I'm talking about the deep applications of AI that will automate and make the enterprises more efficient in jobs other than those information assistance jobs. Think about let's say a editorial environment, or like a journalism or newspaper. Think about people making travel videos. Now these are the kind of jobs that are already getting very significantly impacted. If you have five people involved in creating travel videos for an influencer or for putting on the web on YouTube, now you will only need one or two, and quickly you may not even need that. All you need to do is to describe what you want, and it will create fully synthetic video that you cannot say is created online rather than going to the beach that you portrayed there. So those jobs are going to be affected, and LLMs are incredibly powerful for such jobs. So we got to realize that, and I won't take away anything from the LLM success and its huge impact on job market. Coding, for example, there are they are constantly. Today, I can find a lot of problems with the coding, but it's going to improve, and it is true that a lot of coding will be automated. So these things will be affected quite a bit with LLM itself. What the more important takeaway for this audience is that those powerful LLMs are going to come. Look at Perplexity AI, and you can create very useful interactions with that, and do a great job. I have a company I advise which has used LLM to create a very detailed analysis of electronic medical records for coding purpose. So absolutely wonderful applications are being created by LLMs. However, there will be other set of applications that I'm talking about which will require this next generation of AI that I talked about, and that is where I see India has a. I've been talking to India, to various groups in India on various things. For example, I give this talk. Let me see if I can bring it up. Yeah, so this is the talk that I have recently given towards India's sovereign AI, talent for deep tech research and innovations driving AI products for high value enterprise solutions. So basically, and I was asked to give a presentation by Modi ji at the third annual Chief Secretaries Conference. And what I presented was, okay, here is what is happening, here is what is happening in China and India, which are way ahead from India, sorry, China and US, and they are way ahead than India. What should be the a part that India can focus on and get a competitive advantage against the competition? Where just like India was able to develop very successful IT industry, IT service industry,
Yep.
what is it that we can do in AI so that India has similarly a particular segment of AI in this, that India thrives in and can compete effectively. And India has that knowledge, India has that data, India has other talent, and we may not want to spend $100 million to train a model, but we can use $1 million or less to train a model that will allow them to, let's say, have a very powerful product in finance, in manufacturing, and things of that nature. That is what I was trying to say.
Mhm. Thank you, sir.
Any more questions? Okay, I don't think so. So,
Okay.
myself, Dean of School of Computer Application, KIIT University, Satyaranjan Das. So, thank you, Dr. Amit. The very informative and interesting sessions just now I listened from you. So, many of our intern wants to work with multimodal things. So, definitely, we'll contact you and we can have a collaborative work in future. Thank you, Dr. Samir. Thank you very much.
Bye.
Now for the today's session is over. So tomorrow we'll meet at exactly at 9 o'clock. Dr. Santipriya Parida having the first session. So I will request all to reach at the venue before 10 minutes of the 9 o'clock. Fine.